Hello students, welcome to your chemistry class. In the previous videos, we learned how to name the compounds. In this video, we are going to read about the chemical equation. So let's start. So you know, in all languages, your alphabets make words and your words make sentences. The same way in chemistry language, first the chemical symbols they form the chemical formulae and the chemical formulae form the chemical equations. In our day-to-day life, we see so many chemical reactions. For example, you are cooking your food and burning the candle. So this is your coal is burning here. Okay. So what is happening exactly here? Your coal is burning with the help of your oxygen and it releases the carbon dioxide. So how can we represent this? In the word equation, we can represent like this way. That is coal, that is your nothing but your carbon. So carbon plus oxygen, it gives the carbon dioxide. And in the chemical equation, we can write with the help of the symbols. C plus O2 gives rise to CO2. That means here CO2 is the product. So your chemical equation is nothing but it is mostly about dealing with different chemical reaction. So we can say the definition of your chemical equation that the symbolic representation of a reaction between reactants and products in a chemical reaction is called a chemical equation. So let's read more about this. It is therefore important that we represent chemical reaction in a simple manner. We observe an excellent dazzling white flame when a magnesium ribbon is burnt. So let's see here your picture it is given how your magnesium burns in oxygen to produce a white magnesium oxide powder. Okay. So in the word equation we can write that magnesium plus oxygen and it gives rise to magnesium oxide. So instead of writing this process in the form of a sentence, it can be represented in a shorter form. How? Let's see. So this is your word equation. Okay. This is the shorter way of representing a chemical reaction is called a word equation. So instead of writing this reaction in a long sentence, we can write in a shorter way. That is your word equation. Word reactions concisely represent a chemical reaction. So your left side of the reaction is called your reactants and right side of the reaction is called your products. In a word reaction, the left hand side contains chemicals that react with each other, that is called your reactants. Then, while the new substance formed in the chemical reaction, that is called your products. Okay. Two or more reactants or products are separated by a plus sign between them. That is your this red color you can say. So two or more reactants or products they are separated by a plus sign between them. The change from reactant to products is shown by placing an arrow between them. This is your arrow and this is called your gives rise to. Okay, that means the arrow head pointed towards the products and shows the direction of the reaction. So By seeing this arrow mark, we can say that from this reactants these products are formed. Okay, let us look at another reaction. Calcium carbonate, when heated, gives us calcium oxide and carbon dioxide. So here also you can see, if you represent in the sentence, it seems very long, but if you will represent in the word equation, it looks something lesser as compared to the long sentence. So writing the word equation makes it simpler to express this reaction. So you can say calcium carbonate is the reactant and your product is calcium oxide and carbon dioxide. So you can see this symbol like a triangle. This is your delta. That means that is your heat. If this symbol it is there, that means you have to understood that that is the symbol for heat. Instead of writing HEAT, this symbol it is given, that is your symbol of heat. Word equations can be further simplified by using symbols and formula of compounds. As I told you in the beginning, like in all languages, your alphabets makes words and your words make sentences. Like in the language of chemistry also, the symbols form formulae and the formulae forms the chemical equation. So this is represent here in the chemical equation. So from the word equation, it is represented in the chemical equations. So in the symbolic form, the equation can be written as above you can see. That is calcium carbonate, the chemical formula is your CaCO3, and calcium oxide is your CaO, and carbon dioxide is CO2. Okay, so these are the reactant side and this is your product side. So this is your completely chemical equation. So your chemical equation is nothing but a representation of a chemical reaction using symbols and formula of the substances involved is called a chemical equation. A chemical equation gives us information about the number of reactants and products participating in a reaction. So here you can see, here 1 mole of your calcium carbonate, and when it is reacted or when it is heated, it gives 1 mole of your calcium oxide and 1 mole of your carbon dioxide. So your chemical equation, it represents the number of molecules. So this here it is given your reactant side how much is there, and in product side how much it is there. So you can say in the reactant side your calcium is 1 and in the product side also it is 1. Your carbon is reactant side, it is 1, and in product side also 1. Oxygen in the reactant side it is 3 and product side also it is the same. So the number of atoms of each kind is the same on both the sides of the reaction. So now we can calculate the mass also. How we can calculate? For that, what you have to do, this one we will read in your next videos. It is there how to calculate the how to calculate the mass. Okay, just now you see the example only. Okay, in detail we will read later on. So mass, how you will calculate? For calculating the mass, you should know the atomic number. Okay, so for calcium it is written 40 and for carbon it is 12. Okay, and for oxygen it is 16 into 3. Okay, the total it is came 100 and this side also it is came 100. How it won your 40 of your calcium, how 12 of your carbon, how it is you will read in your next videos. Okay, here only you just see the example. So here you can see that the mass of your reactants and the mass of your products is equal. Okay, so if the mass of your reactant sides and product side are equal, that is called your, that follows the law of conservation of mass. This reaction in terms with the law of conservation of mass, where the mass before and after a reaction remains the same. Okay, so if that follows the law of conservation of mass, that means you have to understood that their mass is same before and after the reaction, it remains the same. Sometimes simply converting a word equation in terms of symbols and formulae does not give us the right equation. See, this one is your magnesium plus oxygen, it gives your magnesium oxide. So it does not follow the law of conservation of mass, because the mass of your reactant side is not equal to the mass of your product side. So this reaction between your magnesium and oxygen, if represented as above, does not obey the law of conservation of mass, because the mass of your reactants and mass of your products are not equal to each other. This equation thus does not tell us the exact number of reactants and products involved in a reaction, as it does not follow the law of conservation of mass. So what is your skeletal chemical equation? A chemical equation that only tells us the reactants and products taking part but not the exact number is called a skeletal chemical equation. So skeletal chemical equation means it just represents your reactant side and product side. It does not tell about your exact number of your reactant side and product side. That's why it is called your skeletal chemical equation. Okay. In the skeletal chemical equation, there will be nothing, only there will be your reactants, products and one arrow mark, that is your Gibbs rise to. Okay. Sometimes you will see the chemical equations like one reactant and two or more products. You can see your calcium carbonate gives rise to your calcium oxide and carbon dioxide. So here you can see your reactant side only one it is there, but in the product side two compounds are there. Okay. Then another thing, if any chemical equation shows two reactants and one products, that is your carbon plus oxygen, it gives rise to carbon dioxide. Then if any your chemical reaction shows two reactants and two products, that is your, in the reactant sides two will be there and in the product sides also 2 will be there. Okay. So these are the different types of your chemical equations. So about this I told you that for heat this triangle symbol we can give. Okay. So if here heat it is written on the arrow mark, that means here heat is an here heat is your reactant. Okay. Then here in the reactant your heat it is not there, but in the product your heat it is there. That means after the reaction your heat is released here. Okay. Then here heat is written in the arrow mark, that means here heat is your reactant and heat is in the product side also. So why it is written in the product side? If the amount of heat is greater than the amount of heat in the reactants, then this will be written in the product sides. Okay, if you will see heat in both the sides, that is in your reactant side and product side, you have to understood that your heat in the product side, it is greater than the heat in the reactant side. Okay, then sometimes you will see in some reactions this type symbols will be there, like your S, L, G, this arrow mark pointing downward and this arrow mark pointing upward. What does that mean? Let's see. So S means your that compound is your in solid state. Okay, if S it is written, then that is in your solid state. If L or AQ it is written, that is your that compound shows that is in liquid or aqueous state. Okay, if G it is written, that is in your gaseous state. Okay, then this arrow mark pointing downward, that is your that represent that something residue or precipitate if it is there. Okay, so this arrow mark shows that the residue or precipitate is there. Then the last one, the arrow mark pointing upward, that means it shows that the gas is evolved or released. Okay, so we have discussed everything about the chemical equation. First thing, we understood that what is your chemical equation and that it consists of your reactants and products. Then we also learned that to separate the reactants and products, there should be a plus sign between them and a arrow mark also should be there. So this was for today's class, and your chemical equation we have finished in this video. In the next video we will see how to balance the chemical equation. Okay, thank you.